All right, so yeah, dealing with only the nucleus and only protons and neutrons, right? So in the nucleus, we have protons and neutrons. So I just want to get you some basics here before we define radioactivity and show you the videos here. So all elements above number 84 are radioactive. Now, you don't really know what that word radioactive, you don't really know what that means until we define radioactivity, so we'll do that. But I like to, again, give you basics before we get into the details here. But this is a little misleading. Smaller atoms have isotopes that are radioactive. And an example would be carbon-14 or cobalt-60. Right now I'm saying things you have no idea what I'm talking about. I doubt, so I understand that. So just get that down. Let me explain a little bit. I'm going to give you a little bit more notes, then we'll write this down, what she said there, and then the videos. All right. So if you look over here to the side, how many protons does hydrogen have? 1. How many neutrons does it have?
0.
0. Now, I want you to understand something. This is really important. Let's just say this here is the size of the nucleus for all atoms if we were to kind of blow it up to a size we could see. So let's say this is the nucleus for every single atom on the periodic table. So no matter what atom it is, the size of the nucleus is the same. You with me on that? I think of elevators. I know it's weird, but think of an elevator as like an empty nucleus. And when people are in the elevator, that's protons and neutrons taking up space. The visual, hopefully if you can do that in your head, you know, an empty elevator would be like this. There's nothing in it. But if we start putting protons and neutrons, it starts to get more crowded. So imagine an elevator with 1 person versus 30 people. Okay, just keep with that analogy. So right now, hydrogen here, we have nothing in it. No, or we do. Sorry, we have 1 proton. What am I saying? So we have 1 proton. 1 proton. Okay. No neutrons. Why? How come it doesn't have a neutron? Mass, right? So 1 minus 1. Okay. Now we're not going to do this with every. It's going to take us, you know, whatever, 2 days to do this. But how many protons and neutrons does helium have? 2 protons, 2 neutrons, right? So helium would have 2 protons and 2 neutrons. Okay. Let's skip ahead, something larger. Let's go to argon. How many protons? 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How many neutrons? 22. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22. Okay. What do you notice about our elevator analogy there, or this nucleus, as we keep getting larger and larger atoms with more and more protons and neutrons? It gets full. It gets crowded is the word I use. Okay? There's less and less space in the nucleus the more and more neutrons and protons. Does everyone understand that? Does that make sense to you? So up here, look over here, when you get to this point, 84, that's kind of like a tipping point. At this point, the nucleus is so crowded, particles actually start leaving the nucleus. So imagine you're in an elevator, it's just you and your friend Matt Payne. Lots of space, probably leaning on the walls, you know, you're probably not going to stand next to each other, right? Talking about the weather. Okay, anyways. You stop at a floor and literally like 35 people come on the elevator, so you're like this. Okay, as soon as that door opens on the next floor, probably people are going to want to get out. Why? You ever been in a really crowded elevator? It's uncomfortable. Okay, some people get claustrophobic, start freaking out. Okay, so they have to get out. The nucleus is the same concept. When this gets super crowded, these particles get real uncomfortable, so some of them want to get out. That's what this is all about. That's what nuclear chemistry is all about. That's what this word radioactivity is all about. That's what this radioactive and radioactivity is all about. a crowded nucleus trying to create space by getting rid of some particles. So it's like a crowded elevator, and then people leave, and then everyone's like, all right, now I got room, I feel better. That's the exact concept behind everything we're going to learn here with nuclear chemistry and the word radioactivity. Radioactivity. So a crowded nucleus is bad, and at 84, the elements, the natural elements, are all trying to get rid of particles from the nucleus constantly to create more space. You can see that if I keep adding dots here, eventually I won't even be able to add anymore because it's too crowded. So this is the first thing I wrote. This is a little more confusing. Smaller atoms like carbon-14, cobalt-60, yeah, they're not above 84. They are also radioactive, and I'll explain that in a little bit, but it's the same concept. Sometimes the nucleus is too crowded and it's unstable. We use the word unstable. So what it does is it gets rid of particles to try and become stable. That's what radiation is all about. That's what radioactivity is all about. Another analogy I use, if you're sick to your stomach, you really don't feel well, sometimes your body will do this. You get food poisoning, let's say. Your stomach, really upset stomach, sick to your stomach. A lot of pain here. You will throw up. Why does your body do that?
Get it out of your system.
To get it out. Usually you feel a little better at some point afterwards. Maybe not right away, but usually you feel a little better. That's what a nucleus does. It throws up. It gets rid of all the bad stuff so it can feel better. That's what radioactivity is all about. So if you use the analogy of the elevator or feeling sick and throwing up, those are good things to really understand what this is all about. Okay? So nuclear chemistry is a very, very unique part of chemistry. It doesn't deal with chemical changes or chemical reactions. It's very different. Because if you start changing the nucleus, what happens to the atom? If an atom loses a proton, it turns into a different element. That's called transmutation. Transmutation is the word we're going to define. So this is a very unique branch of chemistry that elements can actually turn into other elements. How do they do that? They start ejecting particles out of the nucleus. So let's write down all this good stuff that I'm talking about here. And then the video. All right. So, question? No? Fixing your hair? Okay. All right. So, a nucleus that is overcrowded, we'll say. Overcrowded. So we'll say too many protons and neutrons is unstable. In an attempt, bless you, to become stable, the nucleus will emit or eject, we'll say, emit or eject particles. So get rid of particles. I guess that's it. And you're right there. So nucleus is overcrowded. Too many protons and neutrons is unstable. That unstable, I guess I should probably highlight over here, that's called radioactive. It's emitting radiation, giving off particles that can hurt us. That's what they're trying to do to become stable. So in an attempt to become stable, a nucleus will emit or eject particles, and these particles, that's radiation. That's radiation. Another thing I want to add is if the neutron to proton ratio is 1:1, that equals stable. If the ratio is not 1:1, that is unstable. So not 1:1 is 1:1. So a lot of elements, their neutron to proton ratio is 1:1. That means the nucleus is stable. If you have too many neutrons or too many protons, it screws up that ratio, and that's the overcrowded, that's the unstable nucleus. So it's going to start getting rid of particles to try and get that ratio, 1:1. This is not perfect, The best way to explain it, the closer it is to 1 to 1, the more stable it is. The closer it is, the more stable. I don't need to write all the details. This is in general everything you need to know. The concept here of what we're going to be learning about, and I'm running out of time, surprise, surprise, is that if there's too many protons and neutrons, it's unstable and it gives off radiation. Obviously, I'm out of time, so I guess no homework. Tomorrow, I won't show you those videos. And I'll show you